All right, so we're going to cover redox reaction. So redox reaction stands for reduction and oxidation reaction. But before we start, we have to learn about assigning oxidation numbers. So we've heard about oxidation numbers, multiple oxidation numbers, and in general, they tend to be the charge of the ion. But we also have to assign oxidation numbers when you have multiple elements bonded together. And so here are the rules when it comes to oxidation numbers. There's some really, so like in a neutral atom, oxidation number is 0. Group 1 and 2 elements are +2. Halogens are -1. Unless they're with oxygen, then they're usually +1. And so on. Here's some other rules as well. One of the big ones, and we'll go over, but the sum of oxidation numbers in a polyatomic ion, number 9, must be equal to the charge on that ion. So here in phosphate, the charge is -3, so in total it has to be -3. Let's do some examples together, and hopefully it solves some of the issues. So here we have a neutral ion, or sorry, a neutral atom. So it's 0. So the oxidation number of a sodium is 0. Here, if there's an ion, then it's just a +1. So the oxidation number for this is +1. It gets a little more tricky as you have multiple ion or multiple elements. So in this case, we actually know the oxidation of hydrogen. So one of the rules is hydrogen is, in this case, it's -1, but you have 4 of them. And so carbon will be +4. So carbon will have a +4 oxidation number. Hydrogen will have a -1. And we have to know these oxidation numbers when it comes to determining these redox equations. So it's actually we're kind of laying some groundwork of being able to identify oxidation numbers before before actually doing redox reactions. If hydrogen is written like this in the cation position, then this will be a +1, and then leaving -1 for this chlorine. Okay, so sometimes it could be -1. You can kind of see it's in the, you can say the anion position. It's not really anion, but in that second position, it's going to have a negative charge as well. Let's take a look at nitrate. So nitrate is NO3 -1. So one rule is oxygen is always -2. For the most part, oxygen is always a -2 charge. So here oxygen is -2, which means there's 3 of them, so this is -6. Now, this is a polyatomic, so the total charge has to equal -1. So this will make nitrogen a +5. So that means that this piece +5 with a -6 gives you a -1 charge. Sodium nitrate, so NaNO3. So what do you know? Well, you know that sodium is a +1. You know oxygen's a -2 here. That makes this -6, so this should be a +5, right? And so Na is equal to a +1, nitrogen is equal to a +5, and oxygen is equal to a -2 here. And then potassium chlorate, KClO3. So kind of similar, +1, any group 1 metal, +1. Oxygen is going to be a -6, so the chlorine has to be a +5. So potassium is a +1, chlorine is a +5, and oxygen is a -2. All right. So hopefully that helps. If you scroll all the way to the bottom, you'll see some practice, and there's a whole bunch of assigning oxidation number practice.